Hello everyone, welcome to my channel Chemical Engineering Knowledge. In the previous lecture we have discussed about the phase equilibrium. In this lecture we will discuss about the effect of temperature on phase equilibrium. Effect of temperature on phase equilibrium. Let's consider a vessel. This is a vessel. This is our vessel. Let's consider a vessel. This is vessel which is filled with water up to some height. This is the water. Now we enter some air to the vessel. The wall, this is the air. We fill the vessel with some air. After some air, we close the wall and we disconnect the air supply. Then we enter sulfur dioxide to the vessel through a wall. This is wall for sulfur dioxide. This is wall for air. This is sulfur dioxide. So this is sulfur dioxide, this is the air, and this is the water. So after supplying sulfur dioxide to the vessel, we close this wall and disconnect the supply of sulfur dioxide. So we obtained a system like that. This is water, liquid water, the liquid water. This is the sulfur dioxide, and so this is the air. This is the air, this is the sulfur dioxide. So in the vessel two phases are formed. One is the liquid phase and the other is, this is the liquid phase, and the other is gaseous phase. We assume that air is not absorbing into the water, only sulfur dioxide is absorbing in water. So when we took water in a vessel, we enter air and carbon dioxide to the vessel. At the start, the sulfur dioxide was absorbing in the water. After a certain time, sulfur dioxide was absorbed into the water, and equilibrium was reached. At equilibrium, at start the absorption rate of sulfur dioxide in water was very high, but after a certain time some sulfur dioxide was dissolved into the air again and desorption was started. After a certain time the rate of absorption became equal to the rate of desorption, and we said that when the rate of absorption is equal to the rate of desorption, then we said that the system is at phase equilibrium, or the system is at dynamic equilibrium. So let's consider this system. This is the sulfur dioxide, and this is the air, sulfur dioxide and water. Suppose the system is at 15 degree C and it's 1 atm pressure. So we took a vessel, we fill it with water, we enter air and sulfur dioxide. The sulfur dioxide was absorbed in the water, but after a certain time equilibrium was reached at 15 degree C and 1 atm pressure. The system is at 15 degree C and 1 atm pressure. So after when the equilibrium achieved, we determine the concentration of sulfur dioxide in the air and it come out to be YaE1. And when we determine the concentration of sulfur dioxide in the water, it come out to be XaE1. YaE1 show that the concentration of sulfur dioxide in the air during the equilibrium. During the equilibrium, the concentration of sulfur dioxide in the air during experiment number 1 is YaE1. Similarly, XaE1 show us the equilibrium concentration of sulfur dioxide in water during experiment number 1. So, at start, the concentration of sulfur dioxide in the air come out to YaE1, in the liquid it come out to XaE1 at 15 degree and 1 atm pressure. So, after a certain time when equilibrium achieved, we open the valve, this valve, and we enter more and more sulfur dioxide. Again, when equilibrium achieved between the gas and liquid, and when we determine the concentration of sulfur dioxide in air, that come out to YaE2. In the liquid, after equilibrium, the concentration of sulfur dioxide was XaE2. In at equilibrium, the concentration of sulfur dioxide in the air during experiment number 2. At equilibrium, the concentration of sulfur dioxide in the water during experiment number 2. Remember, the A is for the sulfur dioxide, for the component sulfur dioxide. So B is for, suppose B is for component air, A is for sulfur dioxide, and C is for the water. So after certain time, when we open the valve and enter the sulfur dioxide, when equilibrium achieved, the concentration of sulfur dioxide above the water become YaE2, and in the liquid it come out to XaE2. Then we open the valve, enter sulfur dioxide. When equilibrium achieved, we measure the sulfur dioxide concentration in the above air, and it come out to YaE3. In liquid it come out to XaE3. Again we open the valve, enter the sulfur dioxide into the system. When equilibrium achieved, and when we measure the sulfur dioxide in the above space, above the water, it come out to YaE4, and in liquid it come out to XaE4 during the experiment number 4. Again we enter sulfur dioxide, measure the equilibrium concentration of sulfur dioxide in the above air, and measure the concentration of sulfur dioxide in the water, and it come out to be YaE5 and XaE5 during experiment number 5, and so on. We open the valve, measure the equilibrium concentration, we open the valve for certain time, and close the valve, measure the equilibrium concentration, and plot the equilibrium data on graphs. So we obtained various equilibrium points. Then we plot a graph from these equilibrium points: YaE1, YaE2, YaE3, YaE4, YaE5, YaE6, and XaE1 up to YaE1, YaE1 to YaE. Suppose we did 7 experiment, YaE7 and XaE1 to XaE7. So this was the system at 15 degree and 180 m. Now we plot a graph. First of all we make a table from the data from YAE and XAE of various experiments. So first of all we make a table. The table will show us the experiment number. The table shows the experiment number, and this is YAE, XAE. The equilibrium concentration of sulfur dioxide in the air is YAE, and the equilibrium concentration of sulfur dioxide in the water is XAE. During experiment number 1, it is YAE 1, AE1. Experiment number 2, it is YAE2. Experiment number 3 is XAE2, YAE3, and XAE3, up to so on. During experiment number 7, YAE, XAE. So during experiment number 7, suppose experiment number 4, 5, 6. During experiment number 7, it was YAE7, XAE7, and so on. Then we plot these points. These points are called equilibrium points, or the equilibrium data. Equilibrium points. We plot these equilibrium points on graph paper. So we plot the equilibrium points on our graph paper. So this was XA, experiment number 1, experiment number 2, experiment number 3, experiment number 4, 5, 6, 7. This is experiment number 1, 2, 3, 4, 5, 6, and 7. And this is, at start there was no sulfur dioxide in the vessel, there was no water in the vessel, so it was 0. And during experiment number 1, it was XAE1, YAE1. Experiment number 2, it is XAE2 and YAE2. During experiment number 3, it is XAE3, YAE3. During experiment number 4, equilibrium concentration in the gas phase was YAE4. In the liquid phase, it was XAE4. During experiment number 5, the equilibrium concentration in the liquid water was XAE5. In the air, it was YAE5. During experiment number 6, the equilibrium concentration of sulfur dioxide in the water was XAE6. In the gas or in the air, equilibrium concentration of sulfur dioxide was YAE6. During experiment number 7, the equilibrium concentration of sulfur dioxide in the water was XAE7. In the air, it was come out to YAE7. When we connect these all these points, we obtained a linear type curve. This curve is obtained at 180 m pressure and 15 degree centigrade. Now what will happen if we obtain the graph at other temperature like 15 degree, 16, 20 degree, 25, 30 degree? How this curve will behave at various other temperature, at various higher or lower temperature. So let's check it. Suppose again we took a vessel. This was our vessel. This was our vessel. we put some water into it. The water, we enter air to the vessel, enter air to the wall, to the vessel, we enter the sulfur dioxide to the vessel, sulfur dioxide to the vessel, the air, and this is the sulfur dioxide, this is the water. At this time the pressure was 1 atm, but we increase the temperature to 20 degrees C. Let's start that at the first experiment the temperature was 15 degrees and the pressure was 1 atm. And this is the second case. In this case we changed the temperature and the pressure was constant. At this time we fill the beaker with water up to some height. We enter the air and sulfur dioxide. Then we close. After entering air and sulfur dioxide, we close these two valves. We obtained a system like that. We obtained a system like the water and this is the water, this is the sulfur dioxide, suppose this is the air. The system is at 1 atm, but we increase the temperature of the system to 20 degrees C. In this case, first of all we fill the system with water, we enter air and sulfur dioxide. When the equilibrium reached, we determine the concentration of sulfur dioxide in the above air and it come out to YAE 1 dash. When we determine the concentration of sulfur dioxide in the liquid, it come out to XAE dash, XAE1 dash. That means that the equilibrium concentration of sulfur dioxide during experiment number 1 at 20 degrees C. The dash shows us 20 degrees C for simplicity. And XAE1 dash show the equilibrium concentration of sulfur dioxide in the water during experiment number 1 at 20 degree centigrade. Then we enter some more sulfur dioxide to the system. Close the after entering sulfur dioxide, we close the valve. Since the temperature was constant 20 degree, pressure was constant 1 atm. Then after that time we enter more sulfur dioxide to the system. We close the valve, and when the equilibrium achieved, we measure the concentration of sulfur dioxide in the above air and it come out to YAE2 dash. In the liquid it come out to XAE2 dash. In the experiment number 3, we enter more sulfur dioxide, and after entering sulfur dioxide we close this valve and measure the equilibrium concentration of sulfur dioxide in the air and water. In the air the equilibrium concentration of sulfur dioxide come out to YAE3 dash. In liquid it come out to XAE3 dash. Again we open the sulfur dioxide valve, we enter sulfur dioxide to the system again close the valve, and when the equilibrium achieved, we measure the concentration of sulfur dioxide in the above air and it come out to YAE5. Suppose during experiment number 5 it come out to YAE5 dash. In the liquid the concentration of sulfur dioxide come out to XAE5 dash, and so on. You do up to 7 experiments. So we plot points These are the equilibrium points. We plot these points in the table, and from the table we plot a graph, and then from the table we plot a graph. So first of all we will make table from these points, and then we will plot a graph from the table. So during experiment number during second experiment, when temperature was 20 degree and pressure was 1 atm, we plot a graph, we make table. So serial number, experiment number 1, 2, 3, 4, 5, 6, 7. And this is YAE dash. XAE dash. The dash shows 20 degree C. So this is YAE dash XAE dash. So YAE during experiment number 1, YADE dash 1, XAE dash 1. During experiment number 2, it was YAE 2 dash XAE dash 2, and so on. This is YAE dash 6, XAE dash 6, YAE dash 7, XAE dash 7, and so on. So we plot the graph from these equilibrium points. These are the equilibrium points at 20 degree centigrade, 1 atm pressure. So we plot a graph. The graph was like, we plot a graph. This was the graph. This is 1. We plot a graph which is number 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is 1, 2, 3, 4, 5, 6, 7, and this is it. Let's start. The equilibrium concentration of sulfur dioxide in the air was YAE-1. In the liquid it was XAE-1. So we plot this. We make point in this space. During experiment number 2, the equilibrium concentration of sulfur dioxide in the air was YAE-2. In liquid it was XAE-2. During experiment number 3, in the gas it was YAE-3. In liquid it was XAE-3. So during experiment number 4, during experiment number 5, during experiment number 6, during experiment number 7, these were the various concentration of sulfur dioxide in the air and water at 20 degree and 1 atm pressure. So this curve is obtained at 20 degree and 1 atm. Again we do some experiment at 25 degree, 30 degree, 35 degree and 40 degree centigrade, and we make curves for the sulfur dioxide concentration in the air and water, and we obtained a plot like a very important plot. So at various temperature and at 1 atm pressure we obtained various curves like the curves given below. So number 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. At 15 degree C we obtained points like we connect this point. We get 15 degrees C and 1 atm pressure. At 20 degrees C, at 20 degrees C, at 20 degrees C, at 20 degrees C, so when we increase the temperature, instead of absorption, desorption was taking place. So the concentration of sulfur dioxide in the gas phase was increased. So in this case, the concentration of sulfur dioxide in 15 degree was concentration of sulfur dioxide in the gas phase was increased at 20 degree C. So it come out to 20 degree, this point, this point, come out to. So this is at 20 degree C and 1 atm pressure. 20 degree C and 1 atm pressure, the concentration of sulfur dioxide in the gas phase was increased. This is YAE1 dash and this is YAE1. AE1. This is XAE1 dash, this is XAE1. So this is at 20 degrees C. Now if we further increase the temperature, suppose we increase the temperature to 25 degrees, the sulfur dioxide in the gas was further increased. It was further increased. It formed curve like this. This is at 25 degrees C and 1 atm pressure. Similarly, at 30 degrees C, we form a curve like this. This is at 30 degrees C. Similarly, at 35 degrees C, suppose at 35 degrees C, form a curve like this. This is at 35 degree C and 1 atm pressure. So equilibrium concentration of the summary of the lecture is that if we increase the temperature of the system, then the concentration of gas in the concentration of gas in the gas phase will be increases, and more gas will be dissolved to the gas phase, and the concentration of gas in the gas phase will be increases, and the concentration of gas in the liquid phase will be decreases at higher temperature. At lower temperature, the solubility of gases increases, and at higher temperature, the solubility of gases in the liquid decreases. So this is all about the effect of temperature on the equilibrium concentration of sulfur dioxide in the air and water respectively. So this is all about the equilibrium concentration. So if you are new to the channel, please like and subscribe. Thank you very much.